Hey, thanks for clicking in. In this video, we're going to be providing you with a step-by-step tutorial to show you how you can turn clip art like that into a 3D printed object like that. So, don't adjust your internet feed. We'll be right back. Turning 2D clip art into 3D printed objects is an easy thing to do and allows you to quickly and easily prepare a variety of useful things like coasters or key rings or fridge magnets. And using the step-by-step procedures that we're going to cover in this video, you can see how easy that is for you to do yourself. The steps involved in this process are pretty straightforward. We find some clip art that we're interested in on the net. We download it as a .jpeg or PNG or bitmap file, and then we load it into a program called Inkscape, and then we use a function of that program to convert that, what's called a bitmap, into a vector description of the illustration. And then we export a source code file for OpenSCAD, which allows us to both manipulate that image and then ultimately export it as an STL file that we can load into our slicer and then happily print. So the first step is getting ourselves some clip art to download. Now, as I say, just about any sort of black and white clip art will do, but in order to keep us running afoul of any copyright restrictions, I spent a fair amount of time looking around for something in the public domain, and that was accomplished by going to Wikipedia, because Wikipedia does support or has a lot of public domain images, and I selected a skull and crossbones, and that is fairly straightforward. So let's go get a copy of that, or you can simply use the file that was included with the other STL files and program files that are part of this project. But if you want to follow along at home, this is how you do it. We start by opening a browser. I'm using Safari in this example, and typing in the very long URL that will get us to the place where we want to go, or you can just copy and paste the URL from the description below, and that'll bring us to the file that we're looking for. So there we have the file, and as you can see, it is actually what's called an SVG file. And an SVG file is actually the easiest one to convert to an STL file for your printer, but we're going to make it a little bit more difficult in order to provide you with the steps you need to do that will cover most anything you encounter. So even though we could download the SVG file and go straight to OpenSCAD after that, we're going to select the 1024 by 1024 pixel PNG representation of the file. So we click on that, and when the illustration comes up, isn't he pretty? We simply go to the file menu, and we select Save As from the drop-down menu. We can keep the file name the way it is, and we'll just put that right on our desktop. Well, let's clean up the file name a bit. We'll just change it to skullandcrossbones.png. Maybe get rid of the extra period while we're at it. And then we save it. And it's all done. That's basically, we can just quit out of Safari, and that part of our task is complete. And as you can see, there it is up in the top right-hand corner of our desktop. So after we've finished downloading the illustration, we can launch Inkscape. We go to our applications folder as it's displayed on the dock at the bottom, and after a while Inkscape will load along with Xquartz. And at this point, what we want to do is import our PNG file, our .png file, into Inkscape. So we go select import, it's on our desktop, and there's the file we want. So we open it. And what you'll see here are the default options for importing an image, and for our purposes, the defaults are absolutely fine, so you can just click OK. That loads our image, and as I want to remind you, this is a bitmap image, and we want to turn it into a vector description of the object. So we go to the Path menu in Inkscape and select Trace Bitmap. You can see it right there in the menu. And that brings up a dialog, and there's a variety of different options for manipulating the kind of parameters that you can supply to do different things with the bitmap that you've supplied. But for a black and white image like this, the defaults are fine and it'll work really well. So just say OK. And once that's done, it may look invisible, but that's what it did. So you can put the dialog box away. And what we have now is actually a copy of our original bitmap image. And on top of it, directly on top of it, is the vector points of the illustration that were created by Inkscape. So we've got to move what we just created out of the way so we can get rid of the bitmap below. So we click on the black portion of the image. That's our vector. And this one that we've just selected that's under it, that's our bitmap. So now that it's selected, we can get rid of it with a cut. So it's gone. So now all we have is what we need, which is the vector description of the object. And we can use the Inkscape to open SCAD extension and generate the source file we need. So we go to the extensions directory, we go to generate from path, and we select paths to open SCAD. Now this brings up a dialog box that will allow us to set the parameters for this translation process. And the first field allows us to specify where the name of the file that we want the contents to go. And as it stands, where that's going to put it is in our home directory, which isn't really the most convenient place for us to put it. It would be much better if it were actually on the desktop. So when it says output file, it's got a tilde there. Tilde means your home directory. So where we're going to put it is, we want it in our home directory, but let's put it in the desktop of our home directory. So we move the cursor to just after the slash. We type in desktop, capital D for the Mac, and then a slash, and then inkscape.scad. So that's the name of the file that is going to be generated, and it should be put right on our desktop. Now, we're not going to really worry about the height at the moment, because that's something we're going to be playing with ourselves once we load the code that was generated into OpenSCAD. But smoothing, on the other hand, is very important. Now, when this comes up the first time, it'll be set to something like 2 or 1. I can't remember what the default is. And that is just not going to be smooth enough in terms of what your 3D printer is capable of producing. We want to give our illustration a lot more resolution so that there are no rough edges on what we produce on the printer. So this is what we need to do, and this is a little bit of a glitch on this program. I know by experience that a good smoothing factor to work with is 0.01. So we will type in the 0.01, and here's the important thing. Type in 0.01, but do not press tab and do not press return. Immediately after typing 0.01, press apply. And when you do that, it'll generate the source file for OpenSCAD, and you can tell that that is what it's doing because it'll briefly bring up a totally blank window, and then that window will go away because it's finished exporting the file. Now you'll notice that its smoothing says it's at 0.0. That's simply because the field doesn't have enough room in it to display 0.01, but that is what it's set at. Now in order to get that be the default when this dialog comes up in future, you want to make sure you click the close button. And after you've done that, in order to ensure a graceful transition, next time you come in to Inkscape, go to the File menu, select Quit. You can close without saving. We don't need any of that stuff. And then once that's closed, exit or quit out of X11, and we're all set to go. You'll notice that on our desktop, we now have the Inkscape.scad file, and we are ready to move on with the next step, which is loading the file that we just created with Inkscape into the program OpenSCAD. So we go to the applications folder in our dock at the bottom, and when that comes up, we select OpenSCAD, which launches, brings up a dialog, and it asks us to select a file or what our next course of action is, which in this case is open. And we click open, and that brings up a dialog box, which hopefully comes up to your desktop. You'd select that if desktop wasn't selected, and then that'll bring up your Inkscape.scad file, which you'd select, and then open. And then voila, there is your 3D representation of the skull that we downloaded from a PNG file on the internet. Now, as a first step, what we want to do is change some of the default behavior of OpenSCAD because it can be somewhat problematic. If you go to the design menu, you'll see, and click on that, you'll see there's a check mark beside an item called automatic reload and preview. And what that accomplished is what we just enjoyed, was the file being opened and the object we created automatically being displayed. But that's not something you really want to happen all the time, because if you open a very large or complex file and there's problems with it, it can really bog down and take a long time before it doesn't work. So it's best to disable that feature, and you do that by just after having selected the design menu, letting go, unclicking while automatic reload and preview is selected. And if you gracefully quit out of OpenSCAD, that will not happen again. So having done that, let's look at our windows. We have here on the left the file that we created with Inkscape, and that's mostly just a whole bunch of numbers identifying the X and Y points in the skull diagram or in the skull illustration. Directly to the right of that, we have what's called the console window, and that tells you the status of your last operation. And as you can see, it loaded the design, it compiled the design, etc., etc. Now above that is our window of our object. And there are a variety of ways that you can manipulate the image in that window. You can click your cursor and drag it left and right or up and down, and that'll rotate the object. Or you can hold down the Control key while you're doing that and move the entire image up or down or left or right. And then there are some presets along the bottom of the window that allow you to set views explicitly. So there's from the right, or from the top, or from the bottom looking up, or from the left-hand side, and then from the front and from the back. And you can also select the round circle arrow. That'll just give you the default representation. And then there's some zoom keys. You can zoom out, zoom in. And if you're ever in a situation where the object is larger than the window, you can quickly resize it to within the window by pressing the magnifying glass icon, and that will put it at standard default size. Now finally, over on the left there is what's called the preview button. And so that provides a very quick assembly of your object so that you can determine how well your coding is going. And that's what happened when we first opened this window, is it did a quick preview and we saw basically what we see now. Now the other thing that you can do is, after you've finished perfecting your design, you'll want to render your object, as that is the final step just before you export the file to an STL. So we can just try that now. It'll tell you that it's finished with a rendering finished, and there you have it. Once your program is rendered, you can export an STL file from this button above the editor window, but we're not going to do that right now. Instead, when we look at our editor window, you can see that this is a very large file, which is, as I said, mostly just X and Y points for our skull diagram. And it isn't really all that easy to work with. All that data is not really important to us in terms of what we want to do. It just describes the basic skull outline. And we want to manipulate ours at a kind of higher level, not at the point level. So the first thing we're going to do is we're going to create a new file in OpenSCAD, and that comes up, and what we're going to do is type in the OpenSCAD command to include another file in it, and that's done in the following way. Just include, and then a left angle bracket, /users/Vitruvius, that's my username on my Macintosh desktop with a capital D, and then the name of the file, inkscape.scad. And I don't know how that tilde got in there, but let's get rid of that. And now when we do a preview, even though there is only one line in this file, our object gets displayed in the same way that it was when we did the preview from the larger file. So if we go over to our original file, we're going to copy the command that actually instructs OpenSCAD to draw the skull, and then we are going to comment it out so that it no longer has any effect by putting 2 slashes. You can see as we did that, the color of the line changed, identifying its comment. And now we're going to save this file with that command commented out. You can see the console window tells us it was saved, and now when we press the preview icon, no image appears. But let's go back over to the new file that we created with the include statement and paste in the command that does the drawing. So as a first step, the file that we created is included, but we saved it with the command now commented out, but we repeat the command here in the new file. So we do a preview and it still works. So we're looking in good shape now. So let's go back again to the original file and copy this whole little module, because that's kind of what does more or most of the work in terms of making the image displayed. Come back to our new file and we'll paste in that module definition, and there we go. And if we preview it again, we can see that we haven't broken anything. It is still displayed. So we don't need this file open anymore, because the information that we really need we've extracted. So we can just put that file away. We're not destroying it, but we're just not having to look at it as we manipulate the object. So we close it, and now we are just looking at our new window that we created with the include statement. And as a first step, we'll save that, and we'll just call it skull. And we'll put that on the desktop and save it. So here we have our new file, and we have this module definition, and it's currently called poly_path56. Let's give it a better or easier sounding name. We'll just call it skull. And instead of the command executing the old module name, we're going to change that as well and just make it skull again. And as you can see, we haven't broken anything, because when we preview it, it still works. Let's clean things up a bit more. Let's get rid of the scale and these other lines, because we don't really want or need them, but we need to figure out what we're doing. So after commenting out those lines, we re-preview, and you can see that we've accomplished something. It's a different size than it was. It's in a different orientation than it was, and it actually has no height at all. It's a 2D representation of the skull. So now we're going to go backwards and clean some stuff. We're going to get rid of those lines we commented out, and we're going to do our own thing. Now the polygon we leave because that's what actually draws the object, but a 2D object from the points that Inkscape created for us. And we're going to get rid of these parameters, the H and the W. We're going to get rid of them there. And so now we've got a very clean implementation. We press preview and we still haven't broken anything. So what's the first thing we want to do? Well, probably rotate it so it's in an orientation that we're comfortable with. So we use the OpenSCAD command rotate with a left parentheses and then a left bracket. And within those brackets, you have your X, Y, and Z or Z coordinates for any geometric operation you're performing. So we say rotate the X-axis by 0, the Y-axis by 0, and the Z-axis 180 degrees. So let's see what that does for us. Okay, that looks good. It's now facing the way we'd like it to face. We'll move that around. Look at it from straight above. That all looks good. And look what we have now. We can see that our skull is over 200 millimeters wide. That's over 8 inches. That's pretty big. Wasn't what I was really considering. So what we're gonna do is make our object smaller. And we do that with the OpenSCAD command resize. Now, this is a neat little function of OpenSCAD. We type resize, and then we type a left paren and then a left bracket because we're going to type some X, Y, Z dimensions again. And so we type 0 and then 50 for the Y dimension and then 0 for the Z dimension. A right paren, and then we type auto equals true, followed by another right paren. And what that auto equals true does for us is it says any dimension, any axis for which we specified as 0 dimension, we're asking OpenSCAD to figure out what it would be if the resizing is done proportionally. And the only axis we specified was the Y-axis. So we're telling OpenSCAD to resize the Y-axis to 50 and then calculate what the X and the Z dimension should be with a proportional scaling. And let's give that another try. So we preview again, and as you can see, it's much smaller, which is what we wanted. We zoom in, and now we have our object that is 50 millimeters high and as wide as it needs to be. Now, this object of ours, the skull is still, this object still has no height at all. It's still a 2D object at this point. So we're going to use the OpenSCAD command linear extrude, which has a single argument, and that is the height that we want it to be, which let's go with 3 millimeters. So we type in 3 and we readjust our indentation and we do a preview again. And as you can see, our skull is now much taller than it was. Well, it's infinitely taller in a sense because it had a Z height of 0. Let me draw your attention to the OpenSCAD syntax of the program and identify that punctuation is important. And the most important punctuation in OpenSCAD is the semicolon that you'll see at the end of the polygon command. Now, the semicolon comes immediately after what the object of your current command sequence is. So, and every command before that without a semicolon refers to the command immediately preceding the semicolon. So the first thing we do is the last one listed. The last one listed is polygon. So OpenSCAD draws a polygon. Then after that's done, we go back in our list of commands, and the next thing we do is rotate. And then the next thing we do is resize, and then the last thing we do is linear extrude. So in an OpenSCAD program, you list the commands in the reverse order of how they'll be actually executed. Now, if we were to print this as we have it, we'd run into a bit of problem in that the eyes and the two halves of the nose there would be sitting on the build plate all by themselves, and if we remove it from the build plate, it would all fall apart. So what we're going to do is we're going to create a medallion on which our skull is going to rest. Let's create another module definition, and we'll call it skull emboss. And we do that with skull emboss, left paren, left brace, right brace. And the only thing we're going to have skull emboss do right now is run the module skull. And we're going to change our one call to skull to be a call to skull emboss. And now when we render, we get exactly what we had before, and that's not surprising because skull emboss, the command at the end of the file, calls the module skull emboss, which calls skull. Skull does what skull did originally. Now let's get a little bit more sophisticated. Now we're going to make things a little bit more complex. We're going to add the OpenS command cylinder. And we do that by typing cylinder, followed by a D, followed by an equal sign, and what the diameter of the cylinder is supposed to be in millimeters. And then we type an H, which stands for how high we want it, followed by an equal sign. And let's make it 1 high, followed by the semicolon. So it's going to just draw that. And if we render that, you can see there we get our medallion underneath our skull, but our skull is a little bit too far forward. So we're going to fix that up with the OpenSCAD command translate. Type translate left paren, and now we're going to do an XYZ specification again. So a left bracket, we don't want to move it in the X dimension at all. We do want to move it, say 3, we'll give it a try in the Y dimension, and 0 in the Z or Z direction. And we'll fix up the indentation and do another preview. It looks pretty good to me, and that's about it. But there's one last thing we want to do. Let's take a little bit of a zoom in on the medallion. You can see those edges are kind of rough, actually. Well, that's because OpenSCAD draws things with a resolution that defaults to a fairly low number that allows you to preview rather quickly. But when you're actually going to be creating the render for eventual export as an STL file, you may want to increase that default value to something higher. I believe the default is 50, and we're going to double that. And you do that by just using the special OpenSCAD variable called FN, and a special variable is identified by a $sign preceding it. So we just type $FN equals 100, followed by a semicolon. Now let's preview and see what that medallion looks like. Much smoother. So we're in good shape now and we're ready to render the skull, and that'll take a bit of time. You can follow the progress in the bottom right hand corner with the idiot bar. I'll speed things up so you're not spending the rest of your life watching this render. And there we have our skull medallion displayed. So now we can export the STL file by clicking on the STL icon above the editor window. That brings up a dialog box that gives us the opportunity to give a name for our STL file. Because it will have a .stl extension, keeping it with the same name as our OpenSCAD file name is fine. It's going to go on the desktop. And so we just click save, and as you can see, it's just shown up on our desktop. It's an STL file. We come back and save our skull OpenSCAD file, quit out of OpenSCAD, and there's our skull.stl file that we can load into our favorite slicer and print off on our favorite printer. So now we're all done, and we put it in our slicer and we send it off to our printer. And as you can see in the picture-in-picture up there, that's our printer printing off the medallion that we've got right here. Hey, if you've got any comments or questions or concerns, please leave a note for us in the comments below. And if you want to keep on top of what Printable Science is up to, I think you know what to do. Why don't you also take the opportunity to visit our website at printablescience.com, where all the science that fits we print.